All right, let's look at your warm-up. So, some properties you need to know. Transitive property, and you probably were able to guess this. If angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then that means that angle 1 has to be congruent to angle 3. Because if 1 and 3 are both congruent to 2, then they have to be congruent to each other. Substitution, this is one that you've probably heard about in algebra. If the measure of angle 1 equals the measure of angle 2, and measure of angle 1 plus the measure of angle 3 equals 180, then we could replace the measure of angle 1 with the measure of angle 2 because they're the same thing. So I can say then that the measure of angle 2 plus the measure of angle 3 equals 180 degrees. These two properties are properties we're going to use all the time in proofs. So definitely make sure that you put a little star next to those so you can go back and study them. And we are going to be talking about proofs today. Our first proof here is to prove that vertical angles are congruent. Now we already know that they are, but we want to prove that they are. And one thing that's important to know about proofs is that whatever it is that you're trying to prove, that's one of the things that you cannot use in the proof. So I can't say that angle 1 and angle 3 are congruent because they're vertical angles, so vertical angles are congruent. I have to go about it in a different way. So every time you start a proof, the first thing you're going to write down is whatever the given statement is. So in this case, we're given that line M intersects line N, and we're supposed to prove that angle 1 is congruent to angle 3. So the given, the very first thing we write down is that line M intersects line N. And our reason for that is just the fact that it's given. All right, every single proof that you do, that's going to be the first step. Okay, so even if you're not sure what else to write down, you can always write down the given. So statement 1 is always going to be the given. All right, now if I look at this, I know from the last couple of days that not only do I see vertical angles here, but I also see linear pairs. So I'm going to pick a linear pair. In this case, it really doesn't matter which one I pick, but I'm going to choose angle 1 and angle 4. So angle 1 and angle 4 are a linear pair, and I know that linear pairs add up to 180. So my statement is going to be that the measure of angle 1 plus the measure of angle 4 equals 180 degrees. Now, another key part of proofs is that whatever your statement is, whatever angles you're talking about, if you look at what kind of angle pair those are, that's going to help you know what your reason is. So again, I know that 1 and 4 are a linear pair, so my reason for statement 2 is going to be that linear pairs are supplementary. Or I could say linear pairs add to 180. All right, so, whoops, I put an S on linear. Let me fix that. All right, so linear pairs are supplementary. So that's my reason for saying that angle 1 plus angle 4 is equal to 180. All right, now I also have another linear pair that I can look at. I'm going to keep angle 4 in there. Again, I'm keeping in mind that I'm trying to prove that 1 and 3 are congruent. So I've got angle 1 in here. All right, so I want to make sure that the next linear pair that I choose has angle 3 in it. So I'm going to use 3 and 4 because I want to keep the 4 also, just so I have something this same from angle 1. And the air just came on, so hopefully you can still hear me. So my next statement is going to be that the measure of angle 3 plus the measure of angle 4 equals 180 degrees. All right, and again, my reason is that linear pairs are supplementary. All right, and again, every time you make a statement, or if you're trying to fill in the blank, which is what you'll be mostly doing, you look to see what type of angle pair the two angles you used are, and then use what you know about those. So I know linear pairs are supplementary. All right, now in the warm-up, we talked about substitution. So I know that any two things that are equal, I can substitute. Now this is kind of an odd substitution, but we can, since I know that angle 1 plus angle 4 equals 180, and the measure of angle 3 plus the measure of angle 4 equals 180, both of these equal 180. So what I'm going to do is replace the 180, or substitute, actually I'm going to do it the other way. I'm going to substitute the measure of angle 3 plus the measure of angle 4 for 180 degrees here. Those I know are equal to each other. Those are the same thing because they're both 180 degrees. So I can make my next statement, the measure of angle 1 plus the measure of angle 4 equals, and now I'm replacing 180 with the measure of angle 3 plus the measure of angle 4. All right, and I can do that because this, I know this is equal to 180 degrees. So my reason is substitution. All right, now I'm really close to what I need to prove, which is that angle 1 is congruent to angle 3. So if we think about it for a second, if I know that angle 1 plus angle 4 is the same as angle 3 plus angle 4, if we think about it, we know we're adding the same thing to both sides. So if this was an algebra problem, and it really is an algebra problem, I could just subtract the measure of angle 4 from both sides. All right, and if I do that, those would cancel out and leave me with the measure of angle 1 equals the measure of angle 3. And what I did was subtract. So you might remember this property from algebra, you might not remember it, but if you're subtracting something from both sides of an equation, which is what you do when you solve an equation, that's because of the subtraction property of equality. So our reason is subtraction property of equality, and I'm just going to abbreviate that. And now I know that if the measure of one angle is equal to the measure of another angle, then those two angles are congruent. So my last step is going to be that angle 1 is congruent to angle 3. And I know that by definition of congruent. All right, because again, remember the definition of congruent angles is that they're angles that have the same measure. So statement 5 says they have the same measure. So now I can say that they're congruent. And I have finished with that proof. Now, I know that that seems a little bit overwhelming. And it is a little overwhelming at first. But once you get practice at it, you'll get better at these. And they'll get to where they're not so bad. And again, most of the time you're going to be filling in the blank. And we'll look at some of those in just a few minutes. All right, the next proof that we're going to look at together is to prove that alternate interior angles are congruent when the lines are parallel. All right, so again, I'm trying to prove that alternate interior angles are congruent. So I cannot say angle 4 and angle 5 are congruent, so the lines, because the lines are parallel, because they're alternate interior angles. So I can't use that reason, so I've got to use something else. So if I look at the picture, I can see I only have a few things labeled, so it makes it a little bit easier to kind of find our path here. I can see that angle 1 and angle 4 are vertical angles, so that's going to be helpful. I can use those. And 1 and 5, you might recognize those as corresponding angles. Hopefully you're starting to recognize those by now. So I can use those two properties in order to get to what I'm trying to prove, which is that 4 and 5 are congruent. So again, every single proof is going to start with your given statement. So our given statement is that M is parallel to N. Again, remember those vertical lines mean parallel. So M is parallel to N. My reason is given. And again, I want to come up with some plan for proof. So I'm trying to show that 4 is congruent to 5. So I'm going to look at angle 4 first. So I know, again, that angle 4 is congruent to angle 1 because these are vertical angles. So that's going to be my next statement. So I'm going to say angle 4 is congruent to angle 1. And again, the name of your angle pair, along with whatever their relationship is going to be our reason. So 1 and 4 are vertical angles. So my reason is going to be vertical angles. And the relationship for vertical angles is that they're congruent. So I'm going to say vertical angles are congruent. Right now I need to tie angle 5 in there some way, and I cannot say that 4 and 5 are congruent because they're alternate interior angles, because that's what we're trying to prove. So instead, I'm going to see what I can do with angle 1 and 5. And again, 1 and 5, I recognize those as corresponding angles. So my next statement is going to be that angle 1 is congruent to angle 5. Again, the relationship between those is that they're congruent. The name of the angle pair is corresponding angles. So I'm going to say corresponding angles are congruent. And I'm going to abbreviate this if you want to abbreviate these. So corresponding angles are congruent symbol. Makes it a little bit shorter, a little bit less to write. Alright, so now I've got 4 is congruent to 1, 1 is congruent to 5, and I have not used alternate interior angles, so I'm all good. Now I need to link 4 to 5, and so if we think back again to our warm-up, I know that if 4 is the same as 1 and 1 is the same as 5, then 4 has to be the same as 5. So angle 4 is congruent to angle 5, which is what I'm trying to prove. My reason is going to be that transitive property of congruence. Okay, so again, just some little tips for proofs. First statement is always your given. Then from there, we just have to make sure that we do not use whatever it is we're trying to prove. So if we're trying to prove that alternate interior angles are congruent, I can't use the reason that alternate interior angles are congruent when the lines are parallel. I have to use some other method. And again, every angle pair that you list, okay, you're going to use the name of the angle pair along with whatever the relationship is with those. Okay. All right, let's look at one where we're trying to fill in the blanks, which is again more of what you're going to try to do when you're working these out. So this time we're trying to prove that corresponding angles are congruent when the lines are parallel, or when parallel lines are cut by transversal. So in other words, I cannot use corresponding angles are congruent anywhere in my proof. All right, so I've got to use anything else except that one. So again, as I look at my statements, I see the very first thing is M is parallel to N, all right, which is what my given statement is. So my reason that I would fill in is given. All right, statement 2 says the measure of angle 2 plus the measure of angle 3 equals 180 degrees. So what I'm going to do is look at my picture and locate angle 2 and angle 3. So angle 2 and angle 3, they're right here. And then I want to think to myself, what kind of angle pair is that? All right, well, 2 and 3 are next to each other on the same line, so they're a linear pair. So my reason is going to be linear pairs are, and then I have to decide or remember whether those are congruent or supplementary. So linear pairs, we can see here they add to 180, so hopefully that helps us out a little bit. They're supplementary. All right, so I had to find those on the picture and then decide what the angle pair was. That's my reason. All right, statement 3. If I look at statement 3, it says the measure of angle 5 plus the measure of angle 6 is 180 degrees. So if I look at my picture and find angle 5 and angle 6, they're right here. 5 and 6 are also a linear pair. So I can say, same reason here, linear pairs are supplementary. All right, and this one's all filled in for. So this is the same move that we did in the first proof. So I could see that the measure of angle 2 plus the measure of angle 3 was 180, and 5 plus 6 is 180. So I can say then that 2 plus 3 is the same as 5 plus 6. All right, so now I'm going to look at what I'm trying to prove again. So I'm trying to prove that angle 2 and angle 6 are congruent, which means that I'm trying to, at this point in this statement, I need to get rid of the 3 and the 5. Okay, so I need to get rid of these two so that I'm only left with 2 and 6. Well, in the first proof we did, it worked out nicely because we had the same thing there. So we had like the measure of angle 4 and the measure of angle 4. So I could just straight subtract that. But in this case, I can't just subtract it because I don't know yet that these two things are equal. So in statement 5, that's going to help us out with that. Statement 5 says the measure of angle 3 is equal to the measure of angle 5. So now I need to find angle 3 and angle 5 in the picture. All right, so I can see these are angle 3 and angle 5. All right, and so I need to determine what kind of angle pair those are. So angle 3 and angle 5 are alternate interior angles. And I need to know the relationship. Well, I can see here it says that they're equal to each other. I know that that means that they should be congruent. So my reason is going to be that alternate interior angles are congruent. All right, and technically right here we should have said, had an extra step in there to say that 3 is congruent to 5 and then the measures are equal because of the definition of congruent. But just to kind of simplify it, we know if the measures are equal that that's what congruent means. So we're going to not include that step, but that's okay. Now for our final answer for our proof, we do have to have exactly what it says right here. So I can't just leave it at the measure of 2 equals the measure of 6. All right, but number 6 is all filled in for us. So the measure of angle 2 equals the measure of angle 6. The way that we come about that is, in statement 5, we said 3 and 5 were the same. So that means that I could go back to statement 4 and subtract out the measure of angle 3 and the measure of angle 5. And that's still subtracting out the same exact thing from both sides of the equal sign. Now again, some proofs might have you actually rewrite step 4 and say the measure of angle 2 plus the measure of angle 3 equals the measure of angle 3 plus the measure of angle 6 by substitution, and then subtract out the measure of angle 3. But if we already know they're equal, we can kind of pull that off by just making sure that we say that they're equal and then subtracting it. Well, once those are subtracted from both sides, then I know that the measure of angle 2 plus the measure of equals the positive measure of angle 6. Those are the only two things left, which is what statement 6 says. So that's why it's subtraction property of equality, because we subtracted the same thing from both sides. And then our last step is we went from saying the angles measures were equal to now saying that the angles are congruent. That is definition of congruent angles. All right, so that would be our reason. So definition of congruent angles. All right, and again, most of the time you're just going to be filling it in. Now on the end of course test, there will be some that you have to actually do from scratch. So just make sure that you are able to do that. You won't have to do it very much. All right, speaking of the end of course test, this is one of the proofs that they list specifically in this section. A lot of times they just say generally prove angle and parallel line proofs, but this is one they list specifically, so I would imagine that you might see this proof again on the end of course test. You'll probably see it on your quiz next week. You might see it on your test at the end of the unit, because it is one that they specifically list as something you need to know how to do. So what we're trying to do here is prove that the angles in a triangle add to 180 degrees. So in other words, I'm trying to prove that angle 2 plus angle 5 plus angle 6, those are the ones inside the triangle, add up to 180. All right, I'm given that line M is parallel to line N. So again, every proof starts out with your given statement. So statement 1, I'm going to say that line M is parallel to line N, and my reason is given. All right, so I need to figure out something else I know. Well, this is where this proof's a little bit tricky, because there's a lot of things labeled and you're starting from scratch. But one thing that I do know is that I have a straight line here, and every time you have a straight line, angles that form a straight line should add up to 180 degrees. Now, we wouldn't want to say supplementary, because supplementary specifically means that two angles add to 180. But what I can say is that angles that form a straight line add to 180 degrees. So my statement is going to be that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. And my reason, again, is that angles that form a line add to 180 degrees. Okay, so now if I look at what I'm trying to prove, again, I look at the statement here, angle 2 plus angle 5 plus angle 6. Well, I've got angle 2 already in statement 2. So that means I'm going to need to replace angle 1 and angle 5 or 6 and angle 3 with angle 5 or angle 6. So I'm going to look for ways that I can show that angle 1 is congruent to one of these two, or that angle 3 is congruent to one of those two. So I'm going to go back to my picture and look at angle 1. Alright, so angle 1 is right here. If I look at my parallel lines, and I'll look at this transversal that's next to angle 1, and again, I know from what I'm trying to prove that I'm trying to replace it with one of these two, I can see that angle 5 is an alternate interior angle with angle 1. So I can say that the measure of angle 1 equals the measure of angle 5 because alternate interior angles are congruent. So that's going to be my next statement. So the measure of angle 1 is equal to the measure of angle 5. And my reason, again, we look at the type of angle pair, that's an alternate interior angle. Alternate interior angles are congruent. Alright, so now I'm good with angle 1 and 5. Now I need to look at 3. So since I used up 5 with 1, I know that 3 and 6 are the ones that have to go together. So I look at angle 3 here and angle 6, and I can see, again, if I look at the parallel lines and the transversal that's next to 3 and 6, those are alternate interior angles. So I'm going to say for statement 4 that the measure of angle 3 is equal to the measure of angle 6, and my reason is alternate interior angles are congruent. Alright, so some of you might have already figured out, since I know that 1 is the same as 5 and 3 is the same as 6, I can replace those. So my next statement is going to be to replace 1 and 5, alright, and then 3 and 6. I'm going to replace that. So my last statement here, statement 5, is going to be that the measure of angle 5 plus the measure of angle 2 plus the measure of angle 6 equals 180 degrees. My reason is substitution. Alright, now if I look at this, it's not in the exact same order, but is the measure of angle 5 plus the measure of angle 2 plus the measure of angle 6 the same as the measure of angle 2 plus 5 plus 6? Yes. That, if we wanted to rearrange it, we could add a step in there and say that that's the commutative property of addition, because it doesn't matter what order you add numbers in. In other words, 5 plus 2 is the same as 2 plus 5. You get 7 either way. So same thing works for angle measures. So we're done with this proof. So it's a 5-step proof, but again, it's one that you probably really need to know well. All right, next. So again, we're filling in the blanks here, which makes it a little bit easier. If corresponding angles are congruent, then the lines are parallel. So notice this time, instead of proving angles are congruent, we're trying to prove that the lines are parallel. So again, I can't use anything about corresponding angles in order to say that. So I'm given angle 1 and angle 5 are congruent. I can't just write that down and then say because they're corresponding angles and congruent, the lines are parallel, because that's what I'm trying to prove. So same as always though, the first statement's the given. So I'm given angle 1 is congruent to angle 5. Reason is given, that's already written in. The next statement says that the measure of angle 1 plus the measure of angle 4 equals 180 degrees. So again, if I'm filling in the blanks, it makes it a little bit easier. I can just look at the angle measures here. So it says 1 and 4. I'm going to go to my picture and I'm going to find 1 and 4. And then I'm going to see what kind of angle pair those are. So 1 and 4 are a linear pair. Alright, so the angle name, and then I need to know what the relationship is between those. So I know that linear pairs are supplementary. I can see here that they're supposed to add up to 180 according to the statement, so that works out perfectly. Linear pairs are supplementary. Alright, now in my next statement, notice that the only thing that is different from statement 2 to statement 3 is that angle 5 has replaced angle 1. Well, in statement 1, I already said that 1 and 5 are congruent, and really technically I guess we should add in a step here that says that the measure of angle 1 is equal to the measure of angle 5 by the definition of congruence. But again, we know if they're congruent, their measures are the same. So our reason for this statement is that we're just replacing this because we already said they're congruent. That is a substitution. All right, so our reason for that is substitution. All right, and now if I look at the type of angle pair that angle 5 and angle 4 are, okay, so angle 5 and angle 4, if I look at those together, those are same side interior angles. Now, the reason that for statement 3 I couldn't just say that the reason was that same side interior angles are supplementary is because I only know that same side interior angles are supplementary if I already know that the lines are parallel. So since I wasn't given that the lines are parallel, that's what I'm trying to prove, I can't use that fact. I can't say same side interior are supplementary because we don't know that the lines are parallel yet. But since I can get to that same statement by substitution, I can use that now. So I can say that M is parallel to N because of this statement here. Those type of angles, those are same side interior angles. So I can say that when same side interior angles are congruent, the lines are parallel. All right, because again, remember all of those angle pair relationships work both ways. So if the lines are parallel, then your angle pair relationships are true. And then we could say that in reverse. The converse of that is that if the angle relationships are true, then the lines are parallel. So since we were able to show that the same side interiors were supplementary, then we could say that the lines are parallel. Alrighty, so we're almost done with our lesson for today. Last but not least, another fill in the blank. We're trying to prove that if the alternate interior angles are congruent, then the lines are parallel. So again, I can't use anything about alternate interior angles in my proof because that's what I'm trying to prove. So I'm given that angle 5 and angle 4 are congruent. Those are alternate interior angles, but my reason is that that's given. So I can't say they're congruent because they're alternate interior because again, that's only true if I already know the lines are parallel. So angle 5 is congruent to angle 4. First step always is the given. Next thing I see here is that angle 4 is congruent to angle 1. So again, I want to know what type of angles these are. So I'm going to look at my picture and see angle 4 is here and angle 1 is here. Those two angles are vertical angles. So I know that I'm going to start out with vertical angles. All right, I know that they should be congruent based on this statement, and then I think back to my relationships, and I know that vertical angles are congruent. So my reason is vertical angles are congruent. All right, in statement 3, statement 3 has angle 5 is congruent to 1. Well, if I look at angle 5 and angle 1, those are corresponding angles. But again, I only know that corresponding angles are congruent if I already know the lines are parallel. So I can't use corresponding angles. But if I look at my statements here, I know 5 is congruent to 4, 4 is congruent to 1. So again, we got that transitive property happening here, because if 5 is the same as 4 and 4 is the same as 1, then 5 and 1 have to be the same, which is right here. So our reason for this is the transitive property of congruence. All right, and now that I know that my corresponding angles are congruent by transitive property, I can use the corresponding angles here in my reason for number 4. So because I know these corresponding angles are congruent, so I can say when corresponding angles are congruent, then the lines are parallel. Okay, so we are done with that proof. Now I wanted to talk to you for a second about your homework assignment. So if we look at, this is question number 1. It says state the theorem or postulate that proves that line A is parallel to line B. Well, what you're going to do is look to see what kind of angle pair this is. So if I look at this angle is marked and this angle is marked. Those two angles are corresponding angles. So my reason would be that when corresponding angles are congruent, the lines are parallel. Alrighty, so that's what you're going to do for these. You're going to just look to see what type of angle pair you have. That's going to be your reason. If you're trying to show that lines are parallel, you say that if the angles are congruent, or when the angles are congruent, whatever type of angle pair it is, then the lines are parallel. If you're trying to show that the angles are congruent, you're going to say when the lines are parallel, this type of angle is congruent. So corresponding angles are congruent, or whatever the type of angle pair happens to be. All right, another thing on your homework I wanted to show you. Let's scroll down just so to give you a little idea. All right, some of these are just practice problems like you had last night, so same type of problems. This is a plus, by the way. It's kind of hard to see probably on the copy, and this is a minus. All right, if we scroll on down, all right, this one is asking for justification. So angle 2 is supplementary to angle 3. So 2 and 3 are right here. If we look at that, the two lines that matter, the two lines that 2 and 3 are between, are A and B. So you would want to say A is parallel to B. All right, and then that makes these two supplementary because they are the type of angle pair they are, which is same side interior angles. So that's all it's asking for here, is just for you to recognize which pair of lines matters for this statement, and then what type of angle pair they are that makes that statement true. So again, if we look at number 14, 14 is that 1 is congruent to 3. So angle 1 is right here. Angle 3 is right here. So 1 is congruent to 3. Those are along the A and B parallel lines. So A and B are the lines that matter. So we would put A is parallel to B here. And the reason those are congruent is the type of angle pair. So angle 1 is congruent to angle 3 because those are corresponding angles. All right. So go ahead in the time you have left and get started on your homework. Have a great day.